Hello and welcome again to the series which is on machine learning fundamentals. We were discussing previous week advanced clustering, and we had taken several algorithms in that particular category. Some of those were DB-scan, in fact, and then GMM. So we had discussed, in fact, the related concepts that are there to these unsupervised machine learning algorithms in quite a detail. And we are now in a position where we can, in fact, go to some of the concepts that are very essential before we can move to a next level, where it will be, in fact, the reinforcement learning and some of the concepts which are there. And then we will be concluding this series with that. And then there will be separate advanced level series, which will be based on different applications of machine learning in different domains. In this particular episode, which is episode 17, we are going to, in fact, discuss about ensemble learning in machine learning very precisely because ensemble is very important as far as machine learning is concerned. So most of other aspects, I think we have taken at some of them in quite a deeper manner, and some of those at a very fundamental level. We have taken almost all the concepts which are there, but definitely deep dive in some of the complicated, complex concepts that are related to machine learning. That will happen in respective series. That will be dedicated for a specific area of application, and in that area of application, when a specific separate a dedicated series will be there, those concepts will be taken in much more detail. So let me just showcase my slides for this. Ensemble learning in machine learning. So this is something very important, in fact. The performance of machine learning algorithms, and in fact the results that we are getting, that is something very important. And in that particular aspect, it is very important for somebody into machine learning to understand and know what ensemble is, and what are the ensemble methods, and how it is in fact providing benefits and the outcome which is beneficial for overall the outcome of a particular machine learning model. So let us just start this, and I hope that this will be finished within 15-20 minutes. I'm having a couple of programs to show you the implementation aspects as well. I'll be just in a detailed manner providing you some aspects of the results that have been, in fact, that we'll be in fact getting out of those programs, those implementations, very simple implementations. That interpretation will come for the results, so that you can understand the concept practically in a comprehensive manner. So first of all, what is ensemble learning? Ensemble learning is a technique where multiple machine learning models combine. So instead of having a single machine learning model which is giving you an output, and based on that we are taking the results, what we do is we are combining the results of multiple machine learning models, and then we are coming with a conclusive, or you can just say an overall result which has been given by all the models there. We are coming with an with an outcome of all of them. So that is what is an ensemble. So combination of multiple machine learning models, not a single machine learning model. It is as if one example, very good example, which is in fact given in ensemble method is, for example, we are going to a particular doctor, and we are explaining our problem, and then based on our problem, the doctor is diagnosing the problem, and then prescribing a medicine. So instead of instead we rely on a single doctor, we can go to multiple doctors, and we just see what are their expert opinions about the disease, and what kind of prescription, what kind of medicine should be taken. So we can just see if we are going to 4 doctors, or for example 3 doctors. Out of 3, 2 are saying the same thing, and 1 is saying something different. So we'll be going with those 2 who have given the similar kind of prescription, who have recommended similar kind of things, and we'll be going with that. That's an easiest example to understand if we have to understand ensemble, although there are different types, in fact, that also we are going to discuss. it's combining or combined to solve the same problem. So where multiple machine learning models combine to solve the same problem, that is ensemble. So an ensemble is a learning technique where multiple machine learning models are combining together to solve the same problem. The goal is to improve accuracy, robustness, and generalization. So these are some of the aspects that are that we have to consider, and this is going to solve. We are having ensemble with a goal so that it can improve accuracy, robustness, and generalization. The ensemble is based on the principle that multiple weak learners can form a strong learner. So definitely, this is on a concept that if, for example, there are weaknesses of a particular machine learning model that can be, in fact, you can just say that can be taken care by some other machine learning model which is not having that weakness. So if you are having multiple weak models in combination, they can make a strong model. So that is on the basis of this principle we are having the ensemble method. So moving forward, what is the intuition? A single model may mistake, that is true. Different models may make different mistakes, but when they combine together, that will definitely reduce the error, which is overall total error, which will be there, that will be reducing, because any weak aspects of one model will be in fact taken care by other model which is not weak in those aspects, and then vice versa as well. So combining the models will be reducing the total error which will be there. So when it comes to final prediction, it becomes more reliable. It will be providing us better accuracy, it will be providing us more reliability, and we are going to get overall better results when we are combining different machine learning models. That is basically the intuition, the reason behind ensemble method. So real life analogy. So I had given you one example of in real world how we are using, for example, ensemble methods. Medical diagnosis, multiple doctors provide better diagnosis, definitely if it comes to some critical aspects of your health. So when you're taking a suggestion from one recommendation from one doctor, you don't prefer that single opinion, you are just going for multiple opinions, and you see what other doctors have to say, and then you will rely on the one which has been frequently given. That means most of the experts are agreeing with one diagnosis and one cure. So you'll be going ahead with that one prescription which is common amongst those. So that is what exactly happens in ensemble. Voting system is one more. Majority decision is more reliable. Finance, multiple analysts give better predictions. So it is happening in all of these domains where you can just see it in a real life, and you can connect that ensemble with that. Why ensemble? Definitely single models may overfit or underfit. So that we have seen the underfitting and overfitting problem in different machine learning models. Ensemble reduces variance and bias. So we have seen how ensemble can how it can in fact reduce the variance, and it can in fact reduce the bias. It can address both the problems of variance and bias. Improves prediction stability. So it definitely improves the prediction and stability of the prediction. It captures complex patterns in a much better manner compared to a single machine learning model. And those differences and comparisons, we can see them practically as well. I'm going to showcase you two examples that are deployed with Python, and you will see when we are taking a single machine learning model in the same example, and how it is giving better results when we are taking multiple different ensemble methods. Working mechanism is multiple models are trained, each model gives predictions are combined, final output is more accurate. So this is how it flows. And there can be different ways. In fact, we are going to discuss that. Multiple models are trained, each model is providing the prediction, we are combining the predictions, and then we are coming up with a final output that will be in fact much more accurate than having a single model at the first place. Types of ensemble which I was talking about, bagging is one, which is parallel training on different samples. We are going to go into each of these and understand them to a significant extent. Boosting is sequential training focusing on errors, and there is one more, stacking, combining outputs using a meta model. So if we just say the bagging, first of all, go with bagging. What happens in this? In bagging, random subset of data are created. So you are creating subsets of data in a random manner. So you'll be having a data set. First of all, you'll be creating random subsets of the data. So that is, creating subdata. So subsets of the data, same data, you're creating subsets of that. And after that, those subsets are created, each model is trained independently on these subsets. So you are training the model independently on these. And then predictions are aggregated, and then what happens is the predictions which we are receiving, which we are getting from each of the individual models, we are having those as aggregated, and then it can have a significant impact on reducing the overfitting. So random subsets of data are created, then we are each model is trained on those independently. Predictions are aggregated then, so whatever predictions are done by each of the models, they are aggregated, and then we observe that this particular mechanism, this way of ensemble, which is called as bagging, it reduces overfitting to a significant level. So wherever you are facing, for example, the problem of overfitting, you can deploy and employ this bagging ensemble method, and you will see considerable and significant differences as far as the results are concerned, and a reduction in the overfitting. Next one is boosting. Models trained sequentially. So what is this boosting? The models are trained in a sequential manner, not all like we have seen in this bagging. So each model is independently trained. No, here it is sequential. So first of all, one model will be trained, then another will be trained, then another will be trained. Each focuses on the previous errors. So when we are having one model and given the output, and then we are sequentially training one more, the errors that have been done by the previous model, the next one will be focusing on that. It improves the model accuracy, definitely the accuracy, which is the overall accuracy that we are getting with the single model. So it will be improving that step by step, because it happens in a sequential way. So in a stepwise manner, those mistakes, errors that have happened in the previous model and the cycle, those will be addressed, and it will be giving us better accuracy. And there are in fact examples for this. AdaBoost is there, gradient boosting algorithms there. So these are some of the boosting ensemble methods that can be utilized, and in fact it is there to enhance overall accuracy. So that depends upon the use case as well, or the problems you are having in a particular implementation, and then you can use boosting for addressing those. Stacking, one more type, which is in fact multiple models are combined together. A final model learns from the output. So multiple models are combined. A final model learns from outputs, and the produces optimized predictions. So we are combining, first of all, we are stacking them. That's what a stacking means, because we are combining them. Multiple models are combined, they're stacked, and final model learns from outputs. So definitely the outputs which are there, it will be learning from those. Because we'll be giving the training data, and it will be learning from the outputs which are there. And as a result, what we see is the optimized predictions, overall optimized predictions. For example, you might be having a situation where specifically you're not addressing any problem, but overall you want to optimize the results of a particular use case implementation somewhere of a machine learning. So what we can do in that case is you can use stacking method of ensemble to overall optimize the predictions. So example one in this category, which has been given, single model accuracy is there. In, for example, one case, it is coming at 78%. You will see ensemble accuracy will be enhancing it to 88%. So there's a huge improvement. Improved performance using multiple models. So that is one. And then second example can be we are having models logistic regression, for example KNN and SVM. Single model accuracy, if you see of each individual models, that is coming as 80%, and when we are putting ensemble accuracy enhanced to 87%. So combining models improves results, so definitely it will be having a direct impact on the results. And I hope that this thing is clear up till here, that these ensemble methods, why we are using ensemble, what is ensemble first of all, why we are using it, what is the reason for that, and different types of ensemble methods that are there, and what they are beneficial, in which situations they are beneficial. Excuse me. So advantages which are there: higher accuracy, reduced overfitting, better generalization, more stable predictions. So these are all the advantages that we can get with ensemble method. So we can get higher accuracy rates, overfitting can be reduced to a significant level. We can have better generalization, that we in fact had discussed in previous episodes, that machine learning model will be one which will be going with this generalization. So we need to have better generalization. More stable predictions. Definitely with generalization, a model is actually learning, not just remembering things. We had discussed that at the basic level when we were starting this particular series. So more stable predictions with this ensemble. And the limitations are definitely there. What are the limitations? After showing these limitations, I'll show you the practical implementation with two examples. Higher computational cost is there. That is one thing. So these are the limitations in ensemble, because you are doing the same thing with multiple models and then you are aggregating. So this will be resource impact on resource will be there. So there will be a lot of impact on the resources. So computational cost will be more. Processing cost, which is there, that will be higher. Less interpretability. So as far as the interpretability is concerned, because when you are having a single model, you can interpret it in a better manner, but interpretability will be little lesser. More complex to implement. So complexity increases when you are having ensemble methods deployed. So definitely you'll be having complexity. Resource intense, that is one thing. Higher computational cost. Interpretability will be something which will be a little less. And then it is definitely more complex to implement. So these are some of the limitations which are there. And when you should be using the ensemble method. So when to use it. So there are situations in which ensemble can fit. When single model is performing less, it's performing low. So performance of a single model is not that it is not that well. It is not that attractive. So in that case, you can use ensemble. When data is complex and complicated, you can utilize, because when complicated data is encountered by a single machine learning model, it can definitely have impact and implications on the overall results that we are receiving. And that can be handled by by having an ensemble in that. So data complexity is one more aspect. When high accuracy is required, so when you intend to achieve higher accuracy, especially in the areas, for example, like medical diagnosis, where 1% or even 0.5% of increase can have a significant impact. And it's a critical situation. It is in fact we are having predictions which can make difference, and it's a question of life and death. So in such a situation, you can just put an ensemble, so you won't be caring much about the resources. But the what will be, in fact, the motive would be to enhance the outcome of the results. In the similar manner, we can have it in the cybersecurity as well, anomaly detection, some other predictions which are there, which are very critical for identifying and defending a particular threat. So at that time also we can just choose ensemble method. So these are some of the areas. And the key takeaways from here are Ensemble combines multiple models to produce better predictions. That is true. It is powerful machine learning technique. So definitely this is a powerful machine learning technique. And with this, I will be just showing you programs which are there, which you can see Ensemble decision tree. In fact, the first one which is there, and then there is one more which is based on logistic regression, and there are in fact three models that have been combined. I'll be just talking about those as well. First of all, if you just see this Ensemble method which is here, and you can just see that the interpretation, if we are doing, for example, loading the data set, we have not done it for the first time. In fact, we have used this example. This is the same breast cancer data which we are in fact importing from the sklearn, and then we are splitting with the train test split. And then we are using two classifiers here. One is the decision tree classifier, and then there is a random forest classifier. It will be, it may not be out of place to mention here that the random forest classifier is the ensemble of the decision tree that we have already, discussed in quite a detail. We have taken two separate episodes for this, and we have discussed in quite a detail. So you can just see when we are going with the decision tree, in fact, we are getting one level of, so you can just see we are loading the data, and then we are splitting the data set. And in fact, we are then training the single machine learning model. We are taking decision tree single model, and then we are just predicting with this, and then we are having the ensemble of the two. So that means the ensemble method is we are having multiple decision trees that is in the random forest classifier. And when we are getting the results of this, you'll see that there will be 3% of increase in the results. So then we are printing these. So I can just run this. I have given you one by one, the explanation of these steps, which are not new. In fact, in this series, we have taken it multiple times. We have taken decision tree separately with different examples, and then we have taken random forest also with multiple examples. If you just see this, we are getting that, single model decision tree is giving us 92%. This is the confusion matrix which is there. You can just see how many total it has predicted as correct, and positives and negatives which are there correctly, and then there are in fact the mistakes also which are there. So it is saying that benign and malignant in fact scans which are there. And then when we are ensembling it from 92%, it is going up to 95%, almost 96%. And then you can just see from the confusion matrix itself the false negatives that are there. So they have been considerably reduced by 5. And if you just see, in fact, false positives has remained there, but I think, false negatives that are there, which will be having a significant impact. So they are in fact reduced to 2, which will be having, in fact, it will be having impact on all the, different result parameters, whether we are talking about precision, recall, accuracy, FN score, all of these, they will be having an impact. And accuracy improvement is 0.03, so it's almost 3.5% which we are getting, in fact, the improvement in this. And that tells us that how ensemble method can in fact uplift the overall accuracy of a particular use case, and in certain critical cases this is going to be very huge. One more program is there which is in fact based on the ensemble of 3. Logistic regression is there. Then we are having a KNN, and we are having SVC as well. So you can just see all the 3 are there. These 3 algorithms, they are combining. First of all, we see the individual scores which are there, so that can be with the logistic regression, and then we are having in fact the 3 which are there. So if I just give you one by one commentary on this. First of all, we are importing. So we are importing the data from we are importing from different libraries, so that we require here. So if you just see this program 2, which is there, a logistic regression is there. So we are having logistic regression, in fact, imported, and then we will be having SVM, in fact, and KNN is there. So three of them are together. So these are voting classifiers. So they will be putting, in fact, the voting. Each model learns differently, captures different patterns, and then with the voting, we are combining them. So what are the improvements in this? Combining multiple models, in fact, improves prediction and in fact accuracy, because errors are reduced. And definitely we'll be having we can just in fact learn from there how different models see the data in a different manner, and combining them will be addressing different limitations that we are getting individually in the machine learning models. So if you just see this interpretation of this program, first of all, the explanation, so you know that we are importing, for example, pandas as PD from sklearn. We are importing different things. Then these classifiers which are there, in fact, k-neighbor classifier, KNN, logistic regression, and then we are importing SVM as well. So then we are loading the data. If you just see load data set here, so we are loading here, and then in fact this data is loaded, and then we are putting a ciplet in this, so splitting the data. So this is the splitting of data which happens, and then we are feature scaling is done, and then we are putting it first of all into a single machine learning model, that is logistic regression. And with that single machine learning model, when we are predicting it, we are getting the results. So these are the results which are there. In fact, we'll be printing them at the end. And then we are putting the ensemble of logistic regression, KNN and SVM together. So if you just see, these three have been used here in an ensemble method. So this is ensemble model. Voting classifier, three, which is there, voting with the best, wherever you are getting the maximum. And then what we are doing is we are simply printing these results which we have received from the ensemble as well as from a single method of logistic regression. We'll just see how this is providing the results here. So let us go to run and run this particular model without debugging. I'm choosing, so run the Python program. Well, let us just see what exact results we are going to receive. So if you just see the accuracy here, in the logistic regression itself is 100%, I believe, but there will be some other aspects in which we can just see if there are improvements in this. So this data which is there is already having 100% accuracy. Most of the things are good here. But ensemble model voting is reducing that to 97%. So maybe what is happening here is, so this particular model, if you see, it might be, it's very well, in fact, we have discussed it earlier as well. It is very well evident from here that this particular ensemble method is, reducing the overfitting. So instead of having, because we know that, if we are having a data type of a data, for example, anomaly detection, or in fact, the cases of medical diagnosis, we are having just the 2 to 3% of the cases which are in fact those which are with disease. So there can be a problem of overfitting. So when we are having a simple logistic regression deployed, it is giving us 100% result, no problem. But actually, if you just see, model has not done anything. So because 3% or 2% of the cases were actually, disease, but it is detecting them as well as normal, cases. So definitely the model will be predicting it is 100% because it is biased towards, it's overfitted. It is biased towards, a particular, in fact, a particular case, or you can just say underfitting is there. So a particular you are having a one class which is less represented, and then other class is there, so machine learning model is going with that. So definitely the improvement which is there, although it is showing in -2% which is there, but it will be predicting the results in a better manner. So if you'll have those, it will be predicting us in a better manner. So you can just see the ensemble here. It improves the stability definitely, improves diversity and performance. So accuracy, confusion matrix, same as previous classification report, which will be there. But in definitely, if you just see the stability, by repeating the same, it is ensemble is in fact improving here by repeating the same model, bagging and or combining different models, voting. So if you just see this particular example which we have done here, it will be improving in fact the machine learning output to some extent. So in this case, if you just see entirely a different example compared to the first one, and that is good also, because we are having 100% accuracy, but it might not be useful. As we have earlier said, a model is showing 100% accuracy, but as far as the use is concerned, that is nothing. It's zero. So but when we are putting the same thing with ensemble, it improves it. And I think this would have clarified, and you would have got ensemble in quite a detail. You can take some more examples, but as far as realistic application of ensemble is concerned, we are going to take after this couple of 2-3 in fact parallel areas of implementation of machine learning. So it can be anomaly detection on one side, fraud detection on the other side, and then medical diagnosis on one more. So 3 series which are there. In those we'll be using different machine learning algorithms that we have learned from this particular series, and we'll be deep diving into those, and we'll see how they are contributing to these different areas, very critical areas. And in that we'll be taking then ensemble as well. In all of those, in fact, we'll be taking an ensemble method and some other advanced methods as well, not only ensemble, but you will be able to understand that in a quite a detailed, meticulous, deeper manner. But this particular fundamentals here, ensemble, you have understood what is the concept, why we are doing it, and what implications, what impact it is having on overall model accuracy, efficiency, and reliability of the results what we are receiving from there. So with this, thank you so much once again for joining this session, and please provide us your valuable feedback. That will be very critical for us in enhancing the future sessions which are there, whether they are for this particular series or some other series that are in fact planned for the future. So your feedback is going to be very critical, and subscribe to the channel in case you feel that this is beneficial for you. This platform is actually intended for just one thing: to provide a free of cost, without any payments environment for students, for those who are new into machine learning, or who want to learn something, because this is this machine learning, artificial intelligence, cybersecurity, these are nowadays those areas, specializations in computer science, which are in fact they are at the peak, they are being used a lot, and this is with the intention so that it can benefit the community in general, but these specifically to these students, learners who are there, and professionals who want to actually learn this machine learning, artificial intelligence, and cybersecurity concepts. So with that intention, this is there, and we hope that you will be supporting us with this keeping this in mind. And please subscribe to the channel, and so that the future videos which are uploaded, future sessions that are there, they can be you can get an intimation for those. Thank you so much once again for joining this session, and see you on the other side with one more very informative and attractive episode for this machine learning fundamentals.